So this is our today's agenda. In this session, we are going to discuss these topics: decision making statements, loops, conditional branching, and functions. So these four features are also common for almost all programming languages. That's why you can really feel happy while you are learning these concepts. And these are really very, very important because we cannot write a program without using any one of these fundamental features of the technology, whatever the language it can be. And one more thing is, as I said on yesterday, learning programming language is very difficult thing. Definitely it is difficult. That's why one should focus from very first day onwards. Otherwise, definitely you cannot get mastery on the technology. We observe many people are not able to work in the software field, and they said that they are facing a lot of pressures, okay, and tensions, etc., etc., and they ready to resign and they want to switch to other profession. We can observe many such kind of people. The only reason is, the only in the sense 95% or 98%, the reason is the people who do not have the proper command on the technology, who didn't learn properly. Only those kind of people will face such problem in majority of the situations. Of course, in 2 or 3% of the cases there might be some other reasons. That's why, so you have to learn technologies properly, then definitely you can enjoy your career without any doubt. Especially when you are learning a programming language, you should work from very first day, because every feature is important. It is not a subject in your semester just to consider some topics and you can leave some topics for choice. Important topics, some categorization might be there like that, but here when you are learning a technology, there is no such choice here. Everything is important. Data types are important, functions are important, everything is important here. That's why one should practice these features on every day. So at least every day try to write 2 or 3 programs without fail. Then definitely this continuous practice will keep you in the next level. Okay, without delay, let's get started today's session. So the first one we are going to discuss is decision making statements. What is decision making statement? So in our real world, in our daily life, we gone through this process making decision. Whenever you want to start your process, we may have 1 or 2 options. Based on that, we are going to decide what to do and what not to do. So the same kind of scenario can be applied for the programming also, because whenever you write the program, generally the program will execute from the top to bottom automatically. For example, let us see the situation. See guys, here I have arranged the particular VS Code editor as well as console in 2 parts here, just for readability. Otherwise, you can just open them in the 2 separate windows also. So first of all, let me write here. So this is some statement 1 here. Statement 1 I have taken, and I can write statement 2. So the first thing is, guys, here I actually enabled autosave. Okay, so here you can click on it and disable the autosave. So autosave means every time, to avoid saving of this code after making changes, you can just click on file and select autosave. But I strongly recommend to disable that for a few days, because especially when we are writing the programs using loops, we can face a lot of issues because of this autosave mechanism. If someone enabled it, just disable it, because we are going to use this autosave feature later. As of now, if you make any change here, for example, if I write another change here, so every time when you make some change, you can see some number in this icon. Explorer icon is there, you can see some number. Here you can see the number 1. What does it mean? So here one file is modified but not saved. If I, in this project, if I modify 2 files, then it will show the number 2. That means 2 files are modified, but they were not saved yet. So every time when you make some changes here, you may forget to save that file. Then it will alert you to save the file which you have modified. So when all the files are saved properly, all the modifications are saved, then you won't get any number here. As of now, you can see the number 1. The reason is only one file is modified, whatever the modification it can be. It can be either adding a statement or removing the statement or modifying the existing statement. Anything can be considered as the modification of the code. Okay, so now once the modification is completed, we have to save it manually. To save it manually, so you can go to the file and click on the save here, or you can use the keyboard shortcut called Control S. Control plus S also helps us. Now you can see, so that number has disappeared from here, and in the output you can see the output as usual in the console. So here the live server will be reloaded automatically. You no need to actually refresh this browser every time after making the change. Hope you have already observed on yesterday. If you make some change and save that, automatically the browser will be refreshed to get the latest changes. The reason is we are using live server. Actually, how did we open that? We right click in the HTML document and we have selected the option open with live server. Okay, so open with live server option will open this with live running mode. That means in watch mode, whenever you make some changes to your files, the live server will refetch the application from the server, and it will refresh this automatically. So you'll get the latest output here itself. That's why after making every change, you need to just save the document. You no need to refresh the browser, because after saving the document, you will get the latest output here. Okay, that is fine. Now, when you look at this program here, I have taken 3 statements, and the 3 statements are executed in the same order. So first one is statement 1, 2, 3. So they have executed in the same order. This is very simple program, but let us apply this use case for some other things also. For example, let us assume I have written a program of some 100 lines. It is doing some business logic actually. Every time when I run this application, so entire state, all the code will run automatically. That means entire business logic will be executed automatically. But in reality, so the program should understand the situation and it need to execute accordingly. Then we can consider that program as the dynamic program. So human being also have the same tendency. We won't do the same thing repeatedly in every situation. Depending upon the situation, we can try to make some different things or some changes to the existing activity, something like that. In the same way, in programming also, we have to create some mechanism in the program to understand the current situation and to execute accordingly. If we do not provide such an environment here, it will execute the same program every time, whatever the situation it can be. That is not really good. How can we take the program into your control? Control in the sense, we are going to give some intelligence to our program. That means, hey, you have to execute this part when you are doing this one, or when you can execute some other part in this way. Like that, you can take care of these activities. For that purpose, you can take the support of decision making statements. Let us see how can we take the decision making here. So what are the decision making statements we can use in programming? So the first one is we can use the if statement. If statement can be used for simple decision making. In general, when we want to take a decision, every decision will have 2 possibilities, 2 outcomes actually. The decision outcome is always depends upon a condition. Okay, so that if the condition is true, we can make something to execute. If the condition is not true, we can go for some other alternative. That is the meaning of the decision making. So by using this if statement, we can make the simple decision making. That means if the condition is true, then we can decide what to do. If the condition is not true, then here it is not going to help us to decide what to do if the condition is not correct. That's why we can call it as the simple decision making. So when the condition is true, then we can perform some activity, and it won't bother about what have to do if the condition is not correct. We can cover that in the next part. So now let me take this. So here I'm going to demonstrate the if possibility. So if statement. So what is the syntax for if statement means? We have to write the if keyword. If is the keyword. Every programming language contains some keywords. Keyword in the sense, the compiler aware of the meaning of that particular word. For example, if I write some ABCD, so compiler is not aware of ABCD. It leads to errors because it is not the keyword. But if I write if here, so if is the keyword, and also it will show the suggestions here, auto-complete suggestions. Okay, so after the if, you have to write the pair of parentheses. They can be called as the parentheses. After the parentheses, we can write the pair of braces. So within the braces, we can write the statements. For example, let me take this first statement here and keep it in this. So after this if statement, here we have to write some condition. We know the condition should be always either true or false. So for the purpose, I can declare some variable here. Okay, so let me declare some Boolean variable status. Let me take it as true initially. So now I have declared some variable whose status is true, and I can write the status. So here what happened, if the status is true, then this statement will be executed. If the status is not true, this statement won't be executed. Let me save and see what happened. Now, once the condition is right here, it is true. That's why statement 1 is executed. And of course, these two are not depending upon any external conditions. That's why they have executed automatically. For example, let me change this value to false and save this document. Now you can see only statement 2 and statement 3 only. Why this statement is not appearing? Actually, it is not removed from the program. It is still existed here. But why it is not executed means, so if statement will execute its body, we can call this as body of the if statement, or we can call it as the if block also. This if block can have either one statement or many number of statements. So this block will be executed only depends upon this condition. If the condition is true, then it will be executed. If the condition is false, it is not executed. So why it is getting striked automatically means, just you want to know the reason, keep the cursor on it. Now it is saying status is deprecated. So these are some browser issues. Okay, it is suggesting you not to use the status, nothing wrong here, but it is deprecated and it is not recommended. So now I can make this as status value. For example, I can write it as status value. Then let me take this as status value. You won't get that. So when some words are deprecated, it will strike them, but your program will execute. They won't stop your program's execution, but they will give some suggestions to you not to use something there itself in the programming. So now this is 100% clear and everything is working as we expected. But the thing is, if the condition is not true, what is the situation? For example, in this case, the condition is not true, then nothing is happening here. So the user get nothing. But actually the user expects something here, whether the condition is right or wrong. If the condition is right, he expects some behavior. If the condition is not right, some other behavior. But if you consider this part here, it is exhibiting its behavior only when the condition is true. Now the user received some response from the program as statement 1 and it is fine. But the problem is, when the condition is not true, then it is not executing any code here. So the user will receive the empty response like this. To overcome this problem, we can use another decision making statement that is called as if else. So what if else will do is, so here, if the condition is true, okay, then if block will be executed, else will be skipped. If the condition is not true, then if block will be skipped and else will be executed. In simple words, only one can be executed in these two. After the if statement, you can write the status here. Of course, you can write some condition. After the else block, we won't write any condition here. Okay, we won't write any condition after the else. The reason is, every condition will have only two possible values, either true or false. If the condition is true, then if block will be executed. If the condition is not true, what does it mean? There is no third possibility. If it is not true, definitely it is false. When it is false, so automatically what happened? So the else block will be executed. That's why we don't write anything here after the else. We can write the condition only after the if block. Now you can see here, if the condition is true, for example, the user gets some behavior. If the condition is not true also, the user will get some behavior here. So this is the way to understand decision making statements like if statement and all. And this is the flow diagram. The flow diagrams really helps us to understand these kind of activities. See here. So here if statement, it will start and depends upon the condition, it will be decided. So if the condition is true, so the statements within the if block will be executed. If the condition is false, it will reach to the end and nothing to execute there. We have already seen that. Now let's come to the if else. Here what happened? Two possible outcomes are here. If the condition is true, then something is there to execute. If the condition is false, something is there to execute. So one can deal with if, other can deal with the else. Finally, once they execute either if or else, the program will be executed successfully and reach it to the end. So like that, we can work with the decision making statements like if statement and if else statement. But the major difference between these two is if statement can execute some part of the program only when the condition is true. It won't bother the situation when the condition is false. But the if else is more convenient loop, more convenient decision making statement. The reason is, so it helps the user or developer to execute. So in both the cases, whether the condition is true or false, so he can make his program more dynamic. Now let's go for the third possibility. First of all, before going to check the next one, I want to write some meaningful use case. As of now, this is not so exciting here. Okay, so it's not so exciting use case and it's not even very interesting. So let me write some very interesting use case for your better understanding. So what I would like to do is, here I want to take two numbers. For example, let me take the number A here and B. I've taken two numbers. Now I want to find the big number in these two. I would like to write a program to find the big number in these two. So how can we find which is big? Definitely we should go with the what is that, comparison only. Based on the comparison, we can decide which is big and which is not big. So for that purpose, I can use if statement. So if A greater than B, simple condition here. If the A greater than B, simply I can write A is big. Otherwise means, what is the possibility? Else means B is big. Okay, so I can write B is big. So here, let me execute this program. Now you can see B is big. But remember, now the else block is executed. But it doesn't mean every time it is going to execute else block. Depending upon the condition, it decides which to execute, either if block or else block. For example, let me change the value here. Now the A value is 100, B value is 20. Now you can easily observe that the condition will be true because A greater than B, the condition is true. When the condition is true, so if block will be executed and else will be skipped. Now you can see A is big. That means even you write some program here, the entire program is not executing in every situation. Depending upon the situation, it dynamically identify the current situation and execute the specific part of the code, not everything like that. So the best use case to understand the decision making statements is this one. But now let us see a problem here. Now I have taken the two values as same. A is 20, B is 20. Now first let us understand the behavior. First it will check the condition A greater than B. Yes, 20 greater than 20. The condition is false. When the condition is false, immediately it tries to execute the else block and it will give the result as B is big. Now let us see, it is giving B is big. But this is not right answer. Why? Because B, how the B is big here? No way. Because both are equal. But why it is not giving such information to us here? Instead of that, it is giving B is big. The reason is the way you write the program. Simply it can check the condition. If A greater than B, then it will give A is big. If A is not greater than B, it won't care whether they are equal or less than or something. Finally, it is going to execute else block and gives the result as B is big. That's why we got the value B is big. How to fix this problem? To fix this problem, we can use another statement that is called if else if. Okay, so the third decision making statement categorization is there, which is if else if. What is this? It is same as if else actually, but here we can work with multiple conditions. Okay, so here we can work with the multiple conditions actually. By using these multiple conditions, we can take this. As usually, we can write if condition here. If the condition is true, only if block will execute and it will terminate that. If the condition is not true, then it's going to check another condition. If it is not true, it will check another condition. Like that, we can write multiple conditions. Okay, so when we want to deal with multiple conditions, then we can go with if else if statement. As of now, you can observe here we have verified only one condition. If there is only one condition, we can use either if statement or if else combination also. But when we require to work with more than one condition, then we have to use if else if kind of statement. So now I am going to make some changes here. So why it is giving wrong input, wrong output here means we are not verifying its equality. We focused only on inequality of these values. That's why here after the else I can write if A is equal to B. Okay, I can write both are equal. And finally, I can write the else statement, and I can write B is big. Okay, let me save this. Now you can see both are equal. So now let us see here, if this is one condition and this is another condition. Here two conditions are enough. But if you want to work with multiple conditions, then you can write as many else if blocks as you can. So the first condition is here. If the condition is not true, after the else, we are verifying one more condition. If you need to deal with one more condition actually, then after this else, you can write one more if statement here like this. But in this part, it is not required in this use case. So finally, we are getting the right result. Now let us verify, is it still working for the inequality also. Now I have made it as 120, A is big, that is right one. And let me make it as B greater than A, B value 200, we are getting B is big, fine. Now let me make both are equal. Yes, now the program is working perfectly. So that whenever you write the program, just don't check your program with only 1 or 2 inputs. Minimum 5 inputs you need to check, because your program may work fine for first 2 or 3 inputs, but it may fail for the 4th or 5th input. That's why you need to work at least with 5 inputs during learning of your programming. So if it fails at one use case, at least in one use case, your program is said to be incorrect program. It's wrong one. Definitely some issue is there in the logic you have implemented. So you should immediately focus on that logic, correction of that logic itself. Okay, so this is about decision making statements. So that part is completed successfully. So with the help of these decision making statements, we can make the program to behave accordingly. So depending upon the current status or the condition, it can decide which to execute and which not to execute. And it is really simple. So the same thing you learn in C language, and there is no difference in the decision making statements. Of course, when you come to the loops also, the same kind of loops, whatever you learned in C language, you are going to use it here. But in JavaScript, some special advanced loops are also there, but I will teach those loops in future, not on today. Today, we are going to discuss the basic loops which were there from the beginning of the JavaScript itself. And the next important thing is loop. What is looping actually? Looping in the sense iteration. Loop means nothing but iteration. That means executing the same thing again and again. This is another very required behavior in our programming. For example, if we take some daily routine, we will repeat the same routine on every day. Okay, so that every day we wake up by some time, after that we can take the breakfast. So a daily routine will be there. That may be changed from person to person, but he will repeat the same routine on every day. That means some activities in our life we need to repeat every day or many times actually. So the same kind of behavior is required in the programming also. Some part of the program need to execute repeatedly. Many use cases are there. I'm going to explain the concept of looping or iteration by taking 1 or 2 important use cases. So first of all, let us understand how the loops look like. Once we understand this flow diagram, that would be easy to us. As usually, we can start this. So 3 important things here, which are represented in the blue, this one, initialization, condition, post expression. These 3 are the important things for every loop, whatever the loop it can be. Initialization represents where to start the iteration process. For example, if your teacher asks you to write a program for 5 times, for example, then you have to write it starting with 1, 2, 3, 4, 5, or you can start with 5, 5, 4, 3, 2, 1, or you can start with 1, okay, 3, 5, 7, like that. That means 5 times can be counted in any way, but finally it should be done for 5 times. Initialization always represents where to start. Iteration should be started somewhere and definitely it should be ended somewhere. This is very, very important. It should start at somewhere and it should end at somewhere. Otherwise, it needs to infinite loop and it leads to many, many issues. Okay, your program will be crashed totally. So the beginning, where to start the iteration process, where to end, these two are important. Okay, the post expression will take care of how to take the loop ahead, how to move the loop ahead. And also the condition is very, very important, because when the condition is true, then only the loop body will be executed. If the condition is not true, loop body won't be executed. It will close the iteration process itself. That means, in simple terms, until the condition is true, the body of the loop will be executed. If any time the condition is false, definitely it will close the loop. The important thing is the condition should definitely become false at a certain point. If it is always true, the loop will execute continuously, so it will totally freezes the browser and the application will be crashed totally. That's why here at some point, definitely the condition should be false to exit from this loop. So this is the simple scenario about this iteration or looping. Let's write a simple use case for the demonstration of this one. Okay. You can call it as either loop or iteration. Both are same. Okay. So for this iteration process, let me write with a simple thing. Later I can write some specific use cases. Okay. So I can take it as statement 1 here. Let me repeat this for 3 times. This is statement number 2. And this is statement number 3. Save it. You can see it is executed as usual. Here no decision making, no iteration, and it is very normal program. So each statement has executed once from top to the bottom, and finally the end user got the result. So now my thing is, I want to iterate the statement number 2 for 3 times or 4 times, for example. Because let us assume this is some important activity. As of now, it is not an important activity, but let's try to understand that. Why? Because once we understand, we can use this for different use cases, this knowledge. So now let us assume I have a specific requirement here. This particular statement need to be executed for 4 times, but I am not aware of the loops and iteration. Then what I will do, I can simply write the same statement for 4 times. This is only the solution I know as of now. So let me save this program. As expected, we can see statement 2 is executed for 3 times. Now it is executed for 4 times. Statement 1 is for only 1 time. 3 is also for 1 time, whereas statement 2 is for 4 times. The reason is, so this statement need to be executed for 4 times because of some reason in my program. Okay, finally, I achieved it. But the problem is, as of now, this is 1-line statement. That's why you can simply copy pasted this statement. It is fine. But I imagine in place of this single statement, if you have some 10 lines of code, or if you have some 20 lines of the code, what is the situation? You have to repeat the 20 lines of the code for 4 times, means 20 into 4, 80 lines. If the length is 100 lines of the code, 100 into 4, 400 lines, the length of the program will be increased abnormally. And if some error is occurred, it is very hard to find where the error is occurred. These all are very practical problems. Okay, so to overcome these problems, we should not write the same again. In programming, there is a principle called DRY, dry principle, which means do not repeat yourself. That is very important principle that can be applied for every programming. So the best way in programming is, you can write once and try to use it as many times as you need. Don't repeat the same again and again. Then it will be considered as incorrect program. Even though the program is working perfect, it will be considered as invalid program, incorrect program, and inefficient developer you will be considered as. That's why the dry principle is very important. Do not repeat yourself. In the sense, write once and try to use it as many times as you need without repeating the same again and again in your programming. That is called as the dry principle. Now we can achieve this dry principle. One of the ways to implement this is by using these loops. Now what I will do is, I won't write this for 4 times. I can write it for only 1 time, but I can repeat this for 4 times. How can I write the loops? So many loops are there. First one is the for loop, next one is the while loop, and third one do while loop is there, but that is not very important loop. So I didn't use this loop anytime in my 12 years of developer's career. Okay, so just I will teach you the syntax, but that use case is not very specific to our requirements. But in many situations, we can use for loop as well as while loop also. First, let us see what is the syntax of the for loop. We can write the for keyword. After the for keyword, for is also keyword. You can write the pair of parentheses and the pair of braces. And here you are going to write the logic, whatever you want. So whatever the code that you want to repeat, you can place it here. So as of now, it is one statement. If it is even 100 lines of the code, you can keep that 100 lines of the code inside of this for loop. Okay, so what values we should supply here? So we have already seen the first one is initialization. Here we have to inform to this loop, hey loop, please start with this value. So I can take some variable, let x is equal to 1. That means I'm informing to this loop, hey loop, please start with value 1. Now you may ask, sir, why with 1? It's your wish. You may start with 1 or 0 or -1 or 2 or 20, anything it can be. So in this example, I'm taking this as 1. And the variable name, you can take whatever you want. Here, just for example, I have taken x. You can take whatever the variable name here, it doesn't matter. So initialization is ready. After the initialization, you should use the semicolon. After the semicolon, we should write the condition, because here we have seen the condition is next important thing here. First initialization, after that condition, and finally we are going to write the post expression. So what is the condition here? The condition makes everything here. I want to execute this for 4 times. Then I can write x should be less than 4. 4 times means we can write less than or equal to. But as of now, x value is 1. Here I'm checking the condition x less than or equal to 4. So how the x value reach to the 4? Because x is 1, it never reached to 4. That's why here we have to write the post expression. So I can write the colon and I can write x plus plus. So what the post expression will do is, why we can call it as the post expression means, once the loop is executed, then the post expression will be executed. Okay, so first it will initialize x value with 1 and check the condition. If the condition is true, it will execute this loop, the body of the loop. After the execution, then this post expression will be evaluated. So now x value is 1. After the first iteration, x plus plus means it will become 2, and it check the condition again. And if the condition is true, this will execute. Again, it will increment. So once it reaches to 4, so now 4 less than or equal to 4, still the condition is true. This loop will execute for 4th time also. After that, x will become 5, then this condition will be failed. So we can come out from this loop. Let us see, save this. You can see statement 1 is executed 1 time and 3 also, but statement 2 is executed for 4 times. You can see the number here at the left side of that statement. We have taken 4 here. 4 means this statement has executed for 4 times. For example, now I want to execute this 40 times, for example. I no need to write this line for 40 times, just I can change the condition. See here, save it. Now you can see the statement number 2 has executed for 40 times here. If I want to execute this 400 times, I no need to make any change, just adjust the condition, save it. Now the statement is executed for 400 times. So this is the way that you can use these iterations. Okay, now in place of this, you can take any logic. So that logic will be iterated as many times as you like. Here you can decide. Now, sir, instead of starting with 1, I want to start with 10 and I want to make it to execute for 14. 10 to 14 also, it is equivalent to 5 times. 10 to 14, right? So then you can make it as 3 here. 10, 11, 12, 13, 14. Now it is also 4 times. So now you may start with this 20 and repeat up to 23 also fine. Finally, it is happening. So you can decide what is the starting value and what is the condition. So it is not required to start with 1 always or 0 or something else. You can decide in the way you like. And one more thing is here, if I start with 1 and if I write 4 here, okay, for example, if I write some 10 here, then now I no need to write x plus plus every time. I can increment by 2 also. Now you can see x is incremented by 2, so that now it has executed for 5 times. No need to increment by 1. you can increment by 2 or 3, whatever it may be. So initially x value is 1, then it will become 3. After that it will become 5, next 7, 9, 10. So totally 10 times it has executed here successfully. So this is the way that we can execute these programs. But in general, we use it to increment this by 1. At that time, you can write either x is equal to x plus 1, or simply you can write the expression called x plus plus. So that will work out. So this is the way that we can understand these loops. Let us see the syntax of while loop also, and then we can write some use cases for these loops. Okay. So while loop. So while loop also needs the same 3 things. Condition, initialization is required, condition is required, post expression. These all are required for every loop, whether it is for loop or while loop or do while loop. These 3 are mandatory. Without these 3, we cannot create any loop here. So now first one is I need to write the initialization. In the for loop, initialization is part of the loop, but in the while loop, we can write it as a separate one. So let me write some, let y is equal to 1. I can have taken some other variable. So the particular initialization we can write outside of the loop, and then we can write the while keyword. And instead of that, we are going to write the condition y less than or equal to 4, because I want to execute this one also for 4 times. And instead of this, I can write the condition. So some statement, let me keep some statement here. And I can make it as statement 4. Now the statement 3 also will be executed for 3 times. And here I have to write the post expression y plus plus. Save this. Now you can see statement 2 executed for 4 times and statement 3 also executed for 4 times. And finally, we got the same result here. It is for loop and it is while loop. Now you can see which is convenient in these two. That is your personal choice. Okay, either you can use for loop or while loop. Only syntax difference is there. The remaining story is same. Then immediately you may get the doubt. If both are doing the same thing, why 2 here? If there is no difference between these two, why we need to learn 2 loops? Why can't we convince with for loop itself or while loop itself? Yes, there is very minute difference between these two, especially when we are getting data from outside. As of now, our application is not getting any data from outside. But when we are getting data from outside, then while loop is more convenient to use than the for loop. Okay. So very soon we are going to get data from outside also. At that time, I can practically demonstrate the very minute difference between for loop and while loop. Except that minute difference, both are same. Feel free to use whatever you want. Okay. So, but the syntax difference is very important here. For the for loop, you can write initialization, condition check, post expression, all in the same statement in the inline itself after the for keyword. But when we are using a while loop, initialization will be written outside of this while loop, and of course condition you can write here. After these statements, whatever you write, finally you are going to write the post expression. That is the difference between these two. And do while loop is not really important. You can just verify that at your free time. We are not going to use this do while loop anytime in our programming. So this is the concept of these particular loops. Now let us take some real world use case, and then we can go for the next topic. So the use case I'm considering is print first 5 multiples of 3. So what are the first 5 multiples of 3? 3, okay, 6, 9, 12, 15. These are the multiples, right? So how to print the first 5 multiples of these 3? You can do it by using the loops very easily. Okay, so here I can write for, so here I can write let some x is equal to 1. Okay, after that x less than, here I would like to repeat this for 5 times, because we need to find, this need to execute for 5 times, because we have to find only 5 multiples, and every time it can be incremented. This is common. And here I can write 3 into 3. So the multiplication operator and x. That's it. You can see here the first 5 multiples are ready. I write this statement for only 1 time, but you can iterate this as many times as you need. I have iterated for 5 times, so totally we got the 5 values here. For example, if I ask you to find the first 10 multiples of these three, simply I can adjust the condition and save the program. You can get the first 10 multiples of this particular 3 itself. So this is one of the simple use cases to find the values. You can repeat the same by using while loop also. Next use case I want to take, I want to find the factors. Okay, find 4 factors, or simply find factors of some number, anything it can be. For example, I can take 10. Find factors, not 4, whatever the number of factors available. Factor means we know when a number divides 10, get the remainder 0, that will be considered as the factor. So we know the factors are 1 is the factor, 2 is the factor, 3 is not the factor, 4 not 5 is the factor, and finally 10 is the factor. If you take any one of these numbers and divide to 10, so the remainder will be 0. That's why we can consider these are the factors. So how can we write this? So do the same. You can take any variable. Here I'm taking x only every time, but you can take whatever the meaningful variable name you want. So here I have started with 1 here, and x less than or equal to 10. Why? Because this process need to be repeated for 10 times. Okay, and then every time it should be incremented by 1. So what should I do here? I need to check whether it is factor or not. Check factor or not. How can I check the factor or not? So here I can take the if condition. Okay, so if 10 divided by, I'm doing the modulus because I need only remainder here. To check the factor or not a number, I need only the remainder. So if 10 modulus division x is equal to 0, if the remainder is 0, then x will be the factor. So here I can print the value of x. Otherwise it is not the factor, that's why I'm not writing any else part here. Now you can see the factors are 1, 2, 5, because I have not taken equal to. When you write equal to, now you can see the factors are 1, 2, 5, 10. Let me separate these two by writing a simple console statement. Factors of 10. Now you can see factors of 10 are 1, 2, 5, 10. See here, simple logic I have taken. First, it should be iterated for 10 times. Why this loop need to be iterated for 10 times? If you want to find the factors of the number, it should be iterated for those many times. If you want to find factors of 100, for example, so the loop need to be iterated for 100 times, because from 1 to that number, I have to divide that and check whether the remainder is 0 or not. So here, I divided this 10 with x and take the remainder. This modulus operator gives the remainder. If it is 0, it will be considered as the factor. If it is not 0, simply it will be skipped and go to the iteration of this loop again by executing the post expression. Finally, we got this one. So like that, you can write many use cases to use these loops very, very effectively in our programming. Okay, so try these two by using while loop also, and I will give you some another assignments related to this decision making as well as looping. So work with them. Look at that, we are going to use these loop statements also. And the next one that we are going to discuss is conditional branching. This is also sometimes useful to us. It is easy, but it's not very much useful. But sometimes we can take the support of this conditional branching also. What does it mean here? Conditional branching means we can branch to a particular statement based on the condition. Now you may ask, sir, we are doing the same by using decision making, because there also it allows us to branch to the specific part depending upon the condition. Yes, you can do the same by using a conditional branching also in a different way. So sometimes this syntax might be a little bit convenient to you when compared with the multiple if-else kind of statements. Okay, so how can we write this conditional branching? For that purpose, we can use switch statement. The syntax is very simple. Even though it is little bit lengthy, the syntax is simple and we can understand that very, very easily. Let us write the syntax for this conditional branching. First, I will teach you as usually the syntax, and then I will demonstrate this with a use case. Okay, so for this conditional branching, we are going to write the switch statement here. Switch is the keyword we can write, and here the switch will take some value called as the choice. Okay, so we can pass some value called as the choice here, and within the pair of braces, it is going to have the cases. Case 1. Okay, after that, we can write some statements here. Statement 1. After that, we can write the break keyword. I will teach you why the break keyword and all required. Okay, so here I have taken totally 3 cases here. And of course, it is showing error. The reason is we have not supplied any choice to this. So let me write. First, let us see what is the syntax here. Switch is the keyword we can use. The switch always takes the choice to branch to the specific case. So the individual parts are in the form of cases here. When the choice is 1, case 1 will be executed. When the choice is 2, case 2 will be executed. When the choice is 3, case 3 will be executed, and so on. We can compare this with a real world example. When you go to the mobile shop to purchase the mobile, then we won't verify each and every mobile that are existed in the shop. You can directly pick some mobile and you may ask the colors of that mobile or something else. That means even though some 2000 models are available in that shop, you won't verify each and every model from beginning to the ending. You can just pick 1 or 2 models, or if you already decided, you can just ask him about that particular model what you need, and you can verify and you can purchase. That means that is called as direct branching, conditional branching. Without verifying all the other unnecessary things, you can directly point whatever you need. Exactly the same kind of behavior you can provide to the programming by using this switch statement. So how the switch statement executes? It will receive the choice. Based on the choice, the specific cases will be executed automatically. If my choice is 3, it won't disturb either case 1 or case 2. Directly it will execute case 3. If my choice is 2, it won't disturb either 1 or 3. It will directly execute case 2. So case is also the keyword. After the case, you can write the number. Now you can take here as the number or string, anything it can be to represent the case value. And another important thing is, after every case, we have to stop it manually by writing the break keyword. If we do not write the break keyword, so the next cases also will be executed automatically. First of all, let me explain this with a simple example. So I'm taking the choice value as 1. So I'm taking the choice value as 1. We can easily guess the output of this program. If choice is 1, then case 1 will be executed. So statement 1 will be printed. Let me change values. Save this. Now you can see statement 1 is executed here. This is from the line number 39. Okay, that is line number 39. Statement 1 is executed. Fine. If I write the value 2, now you can see statement 2 only executed, but not the remaining cases. If I write 3, statement 3 has executed. That is fine. Let us assume what happened if the brakes are removed. It is same as removing brakes for a vehicle. When you remove the brakes for the vehicle, so it won't stop when we apply the brakes. Okay. So until it collides with some other object. Same story will be here. Let me give my choice as 1. Okay, then what happened means it will take the choice as 1 and executes case 1. But no mechanism is here to break it after the execution of the case. So the control will flow to the next case also automatically. Here also no braking mechanism. It will flow to the case 3 also automatically. Finally, it will execute everything there until it gets a break statement. So it is very dangerous, right? Because in the conditional branching, we should execute only whatever we need, not everything. Definitely, we should provide the break here. For example, here, my choice is 1. I have applied the break only for the case 2. Now, let's see what happened. Statement 1 executed, statement 2 executed, but not statement 3, because at the statement 3, I have applied the brakes. So that is the reason why should we apply brakes for everything. That is the importance of the brakes. Fine. Now the problem is, if the choice is not available here, next one. We can ask the user to give the choice. As of now, we do not have that mechanism at this moment. In future, we can ask the users, hey, enter your choice. Based on his choice, we can give the output. but still we are learning JavaScript. After learning the JavaScript, we can write the program to enter the user some value. But as of now, we do not have that mechanism. So directly I am initializing and changing these values. Fine. If the choice is 10, then it search for the case 10 here. Unfortunately, there is no case with value 10. Then what happened? Save this program and see, nothing happened. The reason is, if no choice is matched, then nothing will be executed. This leads to some problem again, because end user, after supplying him choice, he is waiting for the results. For example, if you ask about your model in the shop owner, he should respond you back, this model is available. Or if, for example, if that model is not in their shop, he should respond with, that model is not available here, sir. If you do not respond, then you will get angry, right? In the same way here, if the choice is available, the specific case need to be executed. If the choice is not available, it should at least inform, hey, that is not available here, that is incorrect choice or something else. So for the purpose, we are going to write the last one, which is the default case. Okay, so the default case is the last one, which can deal with such kind of activities. So let us see its behavior first of all. Wrong choice. Now let me save this. Now you can see it is wrong choice. So if I make this as 1, for example, save it, statement 1. If I give 2 here, statement 2. If I give 3 here, statement 3. If I give 30 here, wrong choice. Now it is working perfect. So the default case, always you need to write at end of all the cases available. And break statement is not required for default, because this is the last one and we are not going to write any cases after this default. That's why the break keyword is not required after this default statement. So the default statement will be executed only when the choice is unavailable. Okay, in the remaining cases, these specific cases will be executed accordingly. This is the simple behavior. Even though it is appearing little bit lengthy, it is quite easy to understand this switch statement. Okay, now let us take some simple use case to understand this switch statement here. So now I want to implement the arithmetic operations. Okay, so arithmetic operations. So just for example, I will take only 4 arithmetic operations here. Of course, you can take the exponentiation as well as modulus, etc., etc. But as of now, I want to keep it simple to take only 4 arithmetic operations. And I can ask the user to enter his choice. Hey, do you want addition or subtraction or division or product, whatever it can be? Based on his choice, my program has to supply the result. So for the purpose, I can declare the variables. So let n1, that means number 1 in my way, that is, and in the same way let n2 is equal to some 5, for example. Okay, and now we are going to write the choice also. Let user choice is equal to, we can write anything here. As of now, let me keep either 1 or let me keep it empty for now, and let's start writing this switch case here. So here I'm going to pass the user choice, and now I'm going to write the case 1. Case 1, I can use it for to find the sum of the 2 numbers. That means let sum is equal to, so n1 plus n2, and then it has to print the sum is comma sum. So this first case is ready. Apply the break here. And in the same way, let's go to case 2 here. So let difference is equal to n1 minus n2. Okay, so difference is, I can write here, and break. And case 3 here, let product is equal to n1 into n2. So product is product and break. So as of now, I'm taking only these cases. After that, I will write the default case. Incorrect choice I have given here. Okay, now let me give my choice as 1 here. Save it. Now you can see the sum is 15. If my choice is 2, I can find the difference is 5. If my choice is 3, so the product is 50. If my choice is 5, for example, so incorrect choice, because I have supplied only 3 cases here, so it should be within that range. So like that here, we can define a lot of mechanism, and you can ask the user which he wants at that moment. This is just an example of arithmetic operations. So you can implement this for anything. So if you have variety of options in your application, you can implement all the options here, and you can ask the user finally, hey, which one you want at this moment. So based on his choice, we are going to use these kind of, we can make it to execute in this way. So that is the story of conditional branching, and it is really easy to use. Okay, this is fine. Now let us discuss about these variable names. Actually, when I'm using the variable names, you can find sometimes I'm using some capital letters, lowercase letters, etc., etc. Let me give some important information about the variables, and then we can go for the next thing. So what are the naming conventions that we should follow for the variables? For example, if you want to declare some variable like let x, you can do like that. We can use either let keyword or constant, whatever it can be. But personally, I strongly suggest you don't use these kind of meaningless variable names, because if I take x, just when I'm writing some sample program for the demonstration, that is fine. But in some meaningful applications, we should not use the variables in a meaningless way. X means it's totally meaningless. Okay, because this variable is going to hold some data. So the data has some specific some meaning actually. So we should reflect the meaning of the data in the variable name. Though that's why here you have to use the specific name. For example, if you want to store the username, then you can write username here. So like that you have to use it. In place of X, if you use, still the program works. But if someone open and check your program, it will be considered as very bad practice. Okay, so that's why here we should use meaningful variable names. Generally, when we are writing the variable names, we use lowercase letters. See here, all lowercase letters, and you should not use the uppercase letters for the variable names, because uppercase letters can be used for the specific purpose like constants, etc. I will teach you later. But except those 2 or 3 use cases, in all the remaining situations, so you should use only lower case to write these particular variable names here. Okay, now the thing is, if the variable name is lengthy, if it has more than one word, for example, if I have some variable like name of the user, if I take some variable something like this, I want to write some specific variable name in this way, some meaningful, and it is lengthy. But the problem is, in English we can write like this by taking proper spaces between these words, so it will improve the readability. Name of the user. Here this variable name contains 4 words actually. Name of the user, 4 words are there. If you write this on the paper, that is fine. But in computer, when you write the variable names with white spaces, it leads to errors. When I save it, you will get the error here. See, unexpected identifier of some error it has given. So the actual reason is, whenever you write the programs here, the variable name should be in lowercase letters generally. But if you have multiple words, so then you have to use camel case. Camel case means first word you can write as usually in the lowercase letters. So when you come to the second word, first remove the white space, make the first word as capital, first character, and here also make T as capital, and here make like this capital. Now no white spaces are there, but still it is readable. Why it is readable? Because the every word is started with the uppercase character. So that's why we can call it as name of the user. This is called as camel case. Its shape is something like a camel, right? So we can call it as the camel case. So whenever you are declaring the variables in your programming, one should follow these rules properly. You are not allowed to write your variable names in the way you like. So some standards are given, some recommendations are made. You should follow those recommendations, and you need to write your programs in such a way here. Okay, so this is called as camel case naming convention. Camel case. We know uppercase and lowercase, but in programming, one more case is there called camel case that can be used for variable names. Okay, yeah. So that's why here, when I'm writing the particular, yes, user choice, actually user and choice, these are the two words. At that time, you should not write the white space here, it leads to error. See, now it is underlined with red color, means it is an error. When you keep cursor on it, it will show the error information here. But if you do not make this as capital, it is not so readable. Still it is correct, but it is not readable. So that if you make the first character of every word from the second onwards capital, it improves the readability. Now you may ask, sir, if I do not make it as capital, if I write like this, will it work or not? Definitely it will work. Definitely it will work. But the problem is, when you look at this name, it will take some time to understand what is meaning of this name, because all characters are grouped together without any proper guidance. That's why here you should follow the proper naming conventions here to get these kind of activities. So this is called as the camel case naming convention. So this is about the conditional branching also. So now we learned about the decision making statements, loops, and conditional branching, and also I have explained you with the specific use cases. So the next concept that we are going to discuss is function basically. So the first important thing is, what is a function? So function means a task. Doing a task is called as the function. It's very simple. For example, let us understand the concept of the function with an example, because in every language functions are there, and function is most frequently used feature in every program, and one should have very strong knowledge about the functions. So today I will teach you very basics of the function, and tomorrow we are going to focus on in-depth details of the functions in JavaScript especially. Okay, so in any language, in any programming language, function means it represents a task. Generally, for example, if you take this example, so if you want to get some chair, for example, from a carpenter, a chair, for example, then what can we do? He won't prepare chair for us immediately. First of all, we have to call him, because he can do some functionality. That functionality is making the chair. That is the functionality he can do. So that when we are calling the worker, we have to provide the materials. So when we are calling the carpenter, we should provide the material and call him. So material in the sense, you may give either money or you can supply the wood material that with you. And finally, once you provide that material and call him, then only he is ready to respond to your request. Otherwise, he won't prepare a chair for you. Okay, once the chair is made, then what he will do, he won't use it, he will return you. Because here you ask him to make a chair for you by supplying some material or cash or something to him as input, then he will do the job. It may take some time. Whenever the task is completed, he will return that. So the important thing is, here this person represents the function. So function won't execute by itself automatically. Just like a carpenter won't make a chair for you without your order actually. So that he is waiting for someone's order. If someone asks him to make a chair, then only he can work for him. And once the chair is completed, the making of the chair is completed, then he can return the result. Result means in this case it is chair to the person who asked him to make it. So here it is the function actually. So the function will never execute. It should be called by someone by supplying some material. Here it is material, but in programming it is data. So if it requires, so it can be supplied with some data and it should be called. When that function is called, then only it will do its job. Whatever the job you have given to that function, it will do that job, and finally it can return the result to you back. This is the simple understanding of the function. You can take many use cases like this. For example, you have the bike and it is time to service your bike. Then what you will do? You can call the service engineer by giving your bike, by handovering your bike to the service engineer. The service engineer won't work for your bike without your message, right? You have to call him and you have to give your bike and money also to him. And if it requires some additional material, then he can complete that work. He can service your bike and fix all the problems of the bike. And finally, he won't use that bike. He can return the bike to you back. These are the very simple and regularly happening use cases to understand the concept of the functions. Yes. So here, finally, what is the use of the functions here? See, one service engine is there so that who can be called for many times for different bikes. Okay, so that one service engineer is there, some 100 members are there, 100 bike users. So they don't need an individual service engineer, so that they can call the same service engineer. They have to hand out their bike. He will complete his job and return their bike to back. And if some 200 members need a chair, they need a carpenter so that he can receive the order from those and make the chairs and return the chairs to their owners back. That means whenever you write the function, so we can use the function as many times as we need. So that is a dry principle implementation. Already in the loops, we have implemented the dry principle. Do not repeat yourself. In the same way here, if you write something in the form of the function, so we can use it as many times as we need by calling the function. Every time when you call the function, it will execute and return the result to us. So we no need to write the function for many times. Write it once and you can call it as many times as you need. So functions are very important in every programming language. So let me demonstrate you how to write a function in JavaScript and how to call, how to return, everything in detail. So now I'm going to create one more program here in this JS file. I can name it as 3.js. And immediately I have to update the name in this HTML document also. Save it. Now it's working. So here, first of all, I would like to declare a function. How to declare a function in JavaScript? In C language, generally, if you want to declare a function, first we can write the data type, right? For example, you can write either void, okay? You can write either void or int or something else. You may write void like this, and after that you can write some function name and something like that you can write. But in JavaScript, it is slightly different. So in JavaScript, what can we do is we can write the function keyword first of all. Okay, every function will starts with the function keyword. That is the keyword. After the function keyword, you are going to write the name of the function. So for the name of the function also, we will follow the same naming conventions. Okay, so lower camel case naming convention, because sometimes the name of the function may be a simple one like this. It may be a simple function like this, or sometimes it may have some lengthy name. If the name contains only one word, then definitely you can use all the things in the very lowercase letters. And finally, it has to return some result. It can return anything. It can return a number or a string or boolean, anything. Here just I am returning this. So function executed. Just it is returning some value. So to return some value from the function, we can write the return keyword. So here we use the function keyword as well as the return keyword. Actually, I have not given any business logic here. Business logic means don't feel it is a complex term, guys. Whatever the logic you write, technically we can call it as the business logic. If you find the sum of two numbers, that is a business logic. Okay, so here I have not implemented any business logic, just given some very basic function here, and it is ready here, and it returns a function. So now let me save this, but in the output you can find nothing. Actually, we are expecting function expected to be printed here, but why it is not printing this one? The reason is whenever you write the function, it won't be executed automatically. Just now I explained you, a service engineer, he won't voluntarily come and service your bike. He should be called by you whenever you need. So the function also need to be called by the program whenever we need that. Otherwise the function won't execute. So how to call the function? Call test function. If you want to call the function, how can we do it, guys? Generally, if you want to call a person, we can call by using his name, by his name. In the same way, if you want to call the function has a name. In this case, it is test. We can call that function, and then we can supply pair of braces. So then only it will be considered as a function call. If you miss this pair of braces, it won't be considered as the function call. So we have to write the pair of braces here to represent this as the function call. Save this. Now this function has executed, But why you are not getting anything in the console? Because you write nothing in the nothing to print in the console in this program. That's why nothing is happening. But the function has executed already. Okay, but I want to check what the value returned by this function. Remember, this returns this value only when this function is called. In this line number 7, this function is called. When this function is called, it returns some value. To receive the value, we have to provide some left-hand side variable. For example, here I have taken some variable called result. Why I have taken the result here? This variable is to store the value returned by this function. Actually, what this function is returning, it is returning some string from here. That string will be assigned to this. If you do not take this variable in this place, then what happened? Even though this function returns, no one is there to respond. It is similar to once the service engineer services your bike and you are not available there, so that he cannot hand over the bike to you back because he tried to contact you and you are not available. That means the bike is ready, service is completed, but you are not able to get it. The reason is sincerely service engineer is trying to try to contact you, but you are not available there. In the same way here, if I call this function, it executed sincerely, it returned the result also. But why we are not getting the result? Because here we have not provided any variable to store the result. So I have taken some variable called result meaningfully, which can get the value returned by this function call. Now I want to see what is that result. Simply I can write the console statement and check it. Save it. Now you can see function executed. So whatever the value returned from here, that will be available. Now in place of the string, if it returns some number, for example, save it. Now you can see that number has returned from here. So a function can return whatever the value. So that value returned by the function will be caught by the function call. So once you call the function, then you need to provide some left-hand side variable, LHS, left-hand side variable. So it will get the value after this function execution is completed. And then we can use the result for the remaining purposes here. This is the simple way to use this. But important thing is inside of the function, finally it can return only one value. You cannot return multiple values from the function. Okay, every time you can return only one value from the function. That is the another important statement. Okay, so the knowledge is clear. Let me write a simple use case to find the sum of two numbers, and I will demonstrate you the power of the functions with this example. So a function to find and return sum of two numbers. So as usually I have to write the function declaration, function keyword. So sum of two numbers. See here I have used the camel case naming convention because it's lengthy name. So here this function, if it want to find the sum of two numbers, it need input. Just like how the engineer requires the input to service your bike, how a carpenter requires material to make a chair for you, this function also requires the inputs to find the sum. So that here I can declare some variables a and b. So as of now a and b are nothing, so these are called as the parameters. We can call it as the parameters. Parameter means the variables taken by the function to receive the input values. Okay, so when you are writing the parameters, you should not declare them like let a, let b, because they are not normal variables, they are just parameters. You can just take the names whatever you want. Here I am taking a and b. So finally it has to find the sum a plus b, and it can return the sum. Okay, now let me save this program. As usually nothing has happened. The reason is this function won't be executed automatically. It should be called. So let us call the function. So sum of two numbers, that is the name of the function here. So when I'm calling the function, definitely I should supply the values. So I already said that when we are calling the carpenter, we have to supply the material. So in the same way, here we are calling the function. This function requires two values to complete the business logic, so that we have to pass the values. For example, at this moment, I want to find the sum of 10 and 20. So I have supplied that. It returns the result here. And let me print the result to the console. Save this. Now you can see the result is 30. Now let us focus on the terminology. A and B are called as the parameters, 10 and 20 are called as the arguments. Okay, so A is the parameter to receive the argument 10. Argument means the real values. 10 and 20 are the real values we are sending, whereas A and B are the variables to receive these real values. So when we pass the argument 10 received by A and argument 20 will be received by parameter B, then 10 plus 20 is 30, it returns the value. Hence, it is completed. Now, what is the benefit of this function? Yes, now I have called this function to find the sum of two numbers here. So now what I will do is, I want to find the sum of other two numbers later. Okay, now let me take some other values here. I want to find the sum of 200 and 300. Now you can see, actually, I have called this function. I didn't write the same logic again to find the sum of 100 and 200. Next, I want to find the sum of some big numbers, whatever it can be. Let me name it as result 2. Save it. You can see the sum is here. So the beauty is the function is defined or declared only once here, but you have used that function for 3 times. First time, second time, and third time. Total 3 times I have used this function. Not only 3 times, even 3000 times also you can use. There is no limit here. So that is the benefit here. Once you write some function, you can use it as many times as you need. So to use the function, your program should call the function. So to call the function, we should use the name of the function. And if it requires data, we should pass the arguments. In the previous example, so it has no parameters. That's why you don't need to pass any values. You can write empty parentheses here. But if the function is a parameterized function, this is called as a parameterized function, which means the function have the parameters. So then we have to supply the arguments. If it is a non-parameterized function, then you no need to pass any arguments. And finally, it can return the result. So to receive the result, we can supply some left-hand side variable. And just I printed the result to the console, but you can use the result to write the remaining business logic also in this place. So this is the way that we can write the functions in our programming. So after completion of the session, try to write some other functions also. For example, today we write finding the factors of a number. For example, to find the factors of a number, here we have taken the same value. For example, find the factors of 10. It is, if you run this program, every time it will find the factors of 10 only. But if you write this logic instead of the function, you can supply the value. Sometimes you need the factors of 10. Sometimes you need the factors of 20, or sometimes you need the factors of 30. You can do whatever you want. For example, let me take this code. Okay, here I can write function to find factors of a given number. Okay, so function, I can write find factors, and here we should get the value. I can write the logic here. X is equal to 1 and x less than n, and here, yes, it should be n here. Okay, so now the difference between this function, this loop and this loop here is, this loop always works for to find the factors of 10 only. It won't reuse helpful to us to find the factors of 20 or 30 until we make some changes here. But when you come to this program, you can supply the value whatever you want. It will give you the results. For example, let me call the function get factors of 10, for example. Get factors of 10 in the sense, simply it is not returning any value because I'm printing to the console. Okay, so in this example, because so many values are here, that's why I'm not returning them. Just for confirmation, I'm printing to the console. So no left-hand side variable is required here. Find factors of 10. Save it. Now you can see the factors of 10 ready. Next one, get factors of 20, for example. So I can write find factors and supply the value 20. Save it. Now we'll get the factors of 21, 2, 4, 5, 10, 20. So now it is more handy to use than this one because it always works for 10, but here it is very generic function. it can receive the value and find the factors of that value. So every time you can pass different values to that to get the factors. Here you can see these two kinds of functions. The first function is returning some value. The second function is not really returning. Instead of that, it is printing and verifying here. Now we write this console.log to check only is it giving the right values or not. Now in place of this, you can write some business logic, whatever you want. But I didn't take return because it cannot return more than one value. But here, every time it has returned so many values from this one, that's why simply I write this logic in this way. Okay, so it is enough for the day, guys. Now you can post if you have any doubts in the WhatsApp group. I can respond accordingly.